Let's jump right in. Welcome to the Explainer. Today, we've got a really fantastic breakdown lined up for you. We're going to look at exactly what it takes to score full marks on question 4 from the Edexcel GCSE Mathematics Higher Paper 3H, going step by step through the required workings.
Here's a quick look at our agenda for today. We'll start by decoding question 4, then cover the acceptable and unacceptable explanations for part A, and wrap up with the first step and final answer for part B.
All right, section 1, decoding question 4. Now for this entire question, we are pulling the exact grading criteria right from the official Pearson Edexcel mark scheme to see exactly how the points are awarded.
Okay, let's dive into this. The main challenge of question 4 revolves around a student named Jenna. See, she tried to plot an inequality on a number line, but she made a few mistakes. So your job as the student is to find those mistakes and then solve an algebraic inequality. We're going to dissect exactly what workings, and frankly, what specific wordings you need to completely conquer this problem.
Moving right along to Section 2, Part A, Acceptable Explanations.
Right off the bat, looking straight at the guidelines, the requirement is, quote, C2 for 2 different correct explanations. Now that C2 basically stands for 2 communication marks. The absolute strict requirement here is that you've got to provide 2 distinct, mathematically sound statements to get full credit. You can't just give one reason and phrase it 2 different ways, right? They literally have to be 2 different mistakes.
So, what actually earns you credit? Well, here is the complete, exhaustive list of every single acceptable example provided in the mark scheme. First, you could focus on the endpoint at 4. You could say she should have a solid, full, shaded, or colored circle at 4. Or just simply state, it does not show that x could be equal to 4. Or you could look at the entirely other end of the number line. You might point out she should have marked a clear or empty circle at -3, or that the line should be drawn down to -3, or honestly just that Jenna started from -2, not -3. Basically, if you jot down any 2 of those distinct points on your exam paper, boom, you lock in your C2 marks.
Okay, next up, Section 3, Part A, Unacceptable Answers.
Listen, if you write any of these down, you are getting 0. Saying both circles should be black is just flat out incorrect. Writing something like 1 circle should be filled in kind of sounds like you're on the right track, but as the scheme strictly notes, you have to say exactly which circle. Vagueness will absolutely cost you marks here. Stating she shouldn't have to reach number 4 is rejected right away, and yeah, obviously claiming Jenna has made no mistakes gets you absolutely nowhere.
Now, what's really interesting about this slide is the direct contrast. Look at the left side. We've got acceptable precision with she should have a solid circle at 4. Now look at the right, rejected ambiguity with both circles should be black. Being vague just shows examiners a misunderstanding of how inequality symbols work. Precision is literally everything.
And wow, here is a massive trapdoor you really need to be aware of. The mark scheme explicitly states, any incorrect statement can be ignored unless it contradicts the statement. What does that mean for you? Well, it means if you write a perfect answer, but then you get nervous, start babbling, and add a contradictory sentence at the end, you lose the mark. Seriously, don't snatch defeat from the jaws of victory by over-explaining. Keep your answers concise, stick only to the facts, and stop writing.
Which brings us to Section 4, Part B. The first step. So for Part B, the narrative shifts from explaining to actually doing. We are solving the inequality. And the very first hurdle is nabbing that M1 mark. Now this is a method mark, and it's awarded specifically just for showing a correct first algebraic step. You don't even need the final answer yet. You literally just have to prove you know how to start the engine.
The original inequality we're looking at is 5y minus 7 is less than 16. To snag that M1 mark, the examiners actually give you a few valid choices. You could show the step of adding 7 to both sides, which looks like 5y minus 7 plus 7 is less than 16 plus 7. Or, if you wanted, you could start by dividing the entire inequality by 5 right out of the gate. You even get the mark for just writing down 4.6, or an equivalent fraction like 23/5 as the critical value in your workings. Show any of those exact algebraic transformations, and that method mark is in the bag.
Now here is a crucial piece of extra guidance that honestly might surprise you. When you're writing out this first step to earn that M1 mark, the examiners are actually incredibly lenient with the symbol you use. You can use any inequality sign, or get this, you can even swap it out for an equal sign and treat the whole thing like an equation, like y equals 23/5. For that very first mark, they only care about your math, not your symbols. Finally, Section 5,
Part B, the final answer.
To get full marks for this whole question, your final answer has to evaluate to exactly this, 4. The mark scheme is super specific that an answer of 4, or y equals 4, earns the final A1 accuracy mark, provided, and this is key, there is no incorrect working leading up to it. Because you gotta remember this ultimate examiner rule. An answer of 4 from incorrect working can score 1 mark at most. So the crucial point is you can't just guess the number 4 out of thin air or happen to stumble into it using deeply flawed math and expect to get full credit. No way! If your working is wrong, the absolute maximum you can score for this entire part is a single mark.
We've just seen exactly how precise you have to be with your words in Part A and just how strictly your methods are judged in Part B. It really kind of changes how you look at a math problem, doesn't it? So I want to leave you with this to think about. If the mark scheme acts as an absolute rulebook, literally dictating the exact boundary between getting a mark and missing it, how will you adapt your own workings to make sure every single step you write down is completely examiner-proof? Thanks so much for joining me on this explainer, and definitely keep that precision in mind the next time you're facing down an exam paper.